everyone. My name is Diana Cheng, and I am a Senior Solutions Architect at AWS for the last 1.5 years. Before working at AWS, I work on Java application development and architecture, and also as a consultant and team lead for over 10 years. I'm really happy to be able to share this short talk with you. So thank you to the organizers at JCON 2021 for this opportunity. I'm okay with any questions that you may want to ask during the presentation. Let me just check on the chat for a second. Awesome. And so if you use the Zoom feature to raise your hand, I would kindly ask our moderator to, in case I don't see it, just unmute himself and let me know. This can happen sometimes, that I miss it. But other than that, yeah, let me first give you a little bit of an introduction as to what we're going to do today, what we're going to discuss today. I've brought a number of topics, and first we're going to go into how we work with AWS in our Java and Spring applications. And this assumes some basic familiarity with AWS as a service platform, but obviously not on an expert level. Then we're going to discuss application configuration and how we can carefully manage application configuration, what challenges does that bring for our application, what impact it can have in our applications, the way we do that. And then we're going to look at some AWS services that helps us with these challenges in managing how changes to configuration reaches our client applications, how we can store that configuration, and how we can deal with sensitive parts of our configuration, such as secrets or credentials, and how we can manage their lifecycle. This is not going to be a comprehensive deep dive of all these services and their features. In this talk, I mainly aim to give you an idea of when to use each of the services, how do they differentiate from one another, and how you can use them within your Java and Spring applications. So yeah, let's get started. If we think about how we work or integrate AWS services into our general Java applications, we typically do this through the AWS provided Java SDK. So you can, for example, reference it from Maven Central, import the bill of materials, and then start adding the modules or the dependencies that you would like to use for the services that you want to work with or integrate with. And this gives us a number of helpful Java APIs, so some facilities to work with the services, and also IDEs of your choice, such as IntelliJ and Eclipse, provide toolkits that integrate tightly with the AWS SDK and help you step through debug, build, and even deploy Java applications directly from the IDE. So that are integrating with the AWS SDK. Nonetheless, this still requires some infrastructure-related code in your application, some, let's say, boilerplate code to integrate with those services. And because of that, we also have Spring Cloud for AWS. And this is a library that helps us consume AWS services in our applications with much less amount of code. And not only that, it also helps us configure a lot of the settings or the settings that we need for working with our AWS accounts the Spring Boot way. This means we can configure things or AWS settings like the region, for example, in our application.yaml file or application.properties file with the notations that we are familiar with. And this is the case because once we include the Spring Cloud starter for AWS, the auto-configure dependency of the starter is included, and that enables Spring Boot support for Spring Cloud for AWS. And also, once you have included the Spring Cloud starter, you get the core module included, and that already provides you the basic dependencies for working with EC2, S3, the simple storage service, and CloudFormation, which are really foundational services of the AWS platform. As you can see in this diagram, Spring Cloud for AWS not only includes the core module, but also other modules that helps us work with other AWS services like Elasticache or ECS. We have JDBC for working with the Amazon RDS service, the managed database service. I'm sorry, Spring. So the AWS messaging module for working with SQS and SNS, so our queue and notification, push notification services. But more importantly, there are also other two modules that are not depicted here in this diagram, which are the AWS Parameter Store configuration module and the Secrets Manager configuration module. And these two modules basically help you use those services as bootstrap property sources. So properties that are loaded during the bootstrap phase of your application can look up those properties directly in Parameter Store and in Secrets Manager. So in the AWS platform. And this is basically, this support is basically very similar to the one that is provided for the Spring Cloud config server or for key value store supported such as console. As I mentioned, we have a number of things to configure in our application when we work with AWS accounts or with AWS as a platform. And one of the main things we have to configure is our AWS credentials in order to authenticate to our account. And we've mentioned that with Spring Cloud AWS, we can configure things the Spring Boot way. So we could, for example, configure our credentials in our application.yaml file or properties file this way, but this is actually something that should be avoided. We shouldn't actually do it this way, even though we can in our Spring Boot applications with the Spring Cloud AWS library included. This actually should only be done if your source code is never going to leave your development laptop, for example. AWS credentials should not land in any code repository, definitely not in a public repository, because it would compromise your AWS account. So a much better way to work with AWS credentials is to use identity and access management, so IAM roles. For example, if you would containerize your Spring Boot application and deploy it in the Elastic Container Services on AWS, you can rely on the credentials relative URI, which gets populated in the service by the agent and which points to the credentials location for the role that is attached for your ECS task. Or if you're working on top of EC2 or on an environment that works on top of EC2, such as Elastic Beanstalk, then you can use the profile credentials, which is also a container for the IAM role attached to the instance, and you can retrieve the credentials in that way, and your application can simply just use them without having to configure or hard code any AWS credentials into your application or your application configuration. So if we take a step back and we ask ourselves what actually application configuration is, let's refer, for example, to what one of the 12-factor methodology is telling us. We know this to be a set of principles for building scalable, maintainable, and portable applications. It's telling us that AppConfig is everything that is likely to change or vary between deployments. So between environments, for example, such as staging, production, or development. And this can include things such as resource handles. So, for example, connection details to databases, to in-memory caches, such as Memcache, or any other backend service that your application is using. It can also include credentials to external services such as Twitter or AWS ones like Amazon S3. And it can also include things that are specific to the deployment environment that you have at hand, such as the hostname for that environment or that deployment. So with that in mind, if we think about how we configure application or how we manage application configuration for Spring Boot applications, sometimes or very often containerized applications. One way to do it would be to bake our configuration in the container image. So basically use Docker commands in the Docker file to drop configuration files in the right places. But this is in fact a bit of an anti-pattern. This goes against the premise of building once and running every once that containers brings to us. In principle, containers should be immutable. And once a container image is built, it should be tested and promoted across environments without changes. So we shouldn't need to make changes to our container every time we want to change things such as configuration. That would require, if we would embed or bake the configuration in our container, to basically rebuild the container image every time. Not only every time we want to change environments, but actually every time we change any bit, a small bit of application configuration. So that's not very good. It's also not suitable for working with secrets because that could get leaked out of the container image. Better way for Spring Boot applications, for Java applications, and also for your containerized applications would be to work with environment variables. So to pass to the application launch time or container runtime, the environment variables containing your part of your configuration. And when we're working with Spring Boot applications or Spring applications, a very good approach is, of course, to pass the Spring profile that should be active. For example, it could be the one for production or the one for development or whatever settings you want to activate at that time. And that helps you pass many less bits of configuration as environment variables. You would pass maybe that one or very few ones, including this one. And then your configuration is actually part of the Spring profile. Another way to do it, and which can be combined, obviously, with using a Spring configuration via Spring profiles, is to externally manage our configuration. So to retrieve it dynamically at runtime from, for example, external key value stores, such as Kubernetes config maps, Spring Cloud config, the Spring Cloud config server, the classic Spring project for this, or for example, from AWS Managed Services. If we think about externally manage our configuration, this in fact has a number of benefits. It will make versioning our configuration much easier. So we separate code and we separate our configuration, and we version each of them independently. This also means we can deploy changes to our application without restarting it. We can reconfigure, or we can make changes to our configuration whilst our application keep running, and then simply deploy that configuration only, and have that apply, or have our applications pull or pull that configuration or push notifications to our application that configuration has changed while the application keeps on running. And we can do a number of interesting things, such as enabling features by feature flags, doing A/B testing, so distributing two versions of the same feature to different user sets, and so on. But if we think about making changes to configuration while our application is running, and for example, if it's running in a production environment, there are of course things that can go wrong. There are some risks that are associated with that. We could, for example, put out application configuration that is broken, that is not valid, and that can break our applications and introduce downtime, which is of course costly for a number of reasons. That can mean that we might have to roll back that application configuration that we just rolled out and revert to the previous configuration version. So in principle, we should be careful with our configuration. We should ideally validate it up front before rolling it out. And when we roll it out, we might want to do this in a controlled manner, in a stepped fashion, so that if there is an impact to our application because the configuration is not in the right shape, we have a limited impact. So as I just mentioned, we have some challenges around application configuration. How do we make it available to our applications? How do we roll it out carefully? How do we roll back if our application gets in fact broken by that configuration version? And how do we actually validate it to avoid errors to our application in the first place? We also talked about storing configuration externally. So which service can help us with this? And in case we have sensitive parts to our configuration, sensitive key values, can these services or can these external key value stores help us encrypt those bits of configuration? And a third challenge, which I would like to mention, is the fact that some parts of our configuration really refers to credentials, to things that we can consider secrets, because it authenticates us against other services, for example. And it is best to actually rotate these secrets continuously over a given period of time, because if these secrets get leaked, then we actually have an impact to our services, we actually have impact to user data, and we might want to minimize that impact by actually limiting the lifetime of those secrets. So we want to manage the life cycle of sensitive information, such as credentials, as part of our configuration. So I'd like to present you some AWS services that helps us with these challenges around application configuration and how to include them in your Java and Spring Boot applications. So for the first challenge of configuration rollout and configuration management, the service that can help us with this is AWS AppConfig. This is really about rolling out new configuration versions. This is actually a capability of the AWS Systems Manager service. It's part of System Managers. You will find it under that service. And it really takes care about application configuration deployment, not about application deployment or rollout itself. This is about rolling out configuration. And it helps us roll out that configuration during the runtime of our application. And it helps us, excuse me, do this in a control or a stepped manner, in a stage manner if we want. It also gives us the functionality of being able to roll back to the previous configuration version and to exactly validate that configuration. So to create validators for our configuration and apply them before we actually do any configuration deployment to prevent any errors. As I just mentioned, this has nothing to do with rolling out changes to our application. At this point, we're assuming that we will follow the best practice of separating our application code and separating our application configuration. And AppConfig will deal with the deployment of our application configuration. The pipeline for deploying changes to our application is something separate, and you'll have to manage that the best way you see fit. AppConfig is actually able to host also our configuration, so it also addresses the challenges of where do we put our configuration, where do we put our key values to be used in our application. But it also integrates with other sources of configuration or other sources or services where we can store our configuration, such as Amazon S3, which is an object store you might know. Also Parameter Store, which is a service we're going to discuss in a moment. And also with Systems Manager document stores is another option that's provided. So you have multiple sources where you can actually store your configuration, and AppConfig will pull that configuration from those, or it can also store the configuration for you in a string form, in JSON form, in YAML, or also key value form. AWS Spring Cloud does not include a module for AppConfig. So when you use it in our applications, the integration would be directly with the Java AWS SDK. So you would include the AppConfig dependency, and you would invoke the get configuration API. So we're going to see how that works in a second. This is the way our applications are are going to be retrieving the full set of configuration. They're going to make that call via the Java SDK. And typically applications will cache that configuration for a period of time. The service charges you for every call that you do to the get configuration API. So ideally you would cache it and keep it for a period of time, caching your applications. I'm sorry. So if we take a look at how we're going to work with AppConfig and how it lets us do all these things that I just mentioned. When you go to AppConfig and you log into your account or work with your account, maybe also from the CLI, you're working within a region, and within your account and a region, you can create applications. You can define applications within AppConfig. Obviously, you might have one or many applications for which you want to manage configuration, and you simply give it a name. It's really easy. As part of our applications, we obviously will manage different environments typically as well. You can have one or multiple environments. And again, you give it a name, easy as that. And very crucially, AppConfig allows us to define monitors. So a way to monitor each environment for our application. And it will do that through the usage of CloudWatch alarms. CloudWatch alarms are alarms or that are tied to metrics that tells us something about the health of our application. Metrics such as the number of 500 response codes that are originating from the load balancer in front of our application. If this exceeds a certain threshold per minute, then we know something is going wrong with our application. That shouldn't typically be the case. So we can include an alarm that tracks a number like that, and that goes to red or goes into alarm when this threshold gets exceeded. And we associate it as a monitor to our environment. This will tell AppConfig that when a deployment of configuration has been done against that environment for that application, if that alarm has gone into the alarm state, then something has gone wrong and it should roll back to the previous application configuration version. So that's quite useful, I think. Besides from defining applications and environments, we also can define the way in which we deploy or the way in which we make available the new configuration to our applications. This is called a deployment strategy. And AppConfig will have a number of deployment strategies available for you, but you can also define your own. So you can create custom deployment strategies. And when I say deployment strategies, the way we make the configuration available, this means, for example, how do I increase the number of my running instances that get that new configuration? During what time of period do I make that configuration available to new instances of my application? So I can say, hey, increase the number of targets that of my application or running instances of my application that get access to this configuration in a linear fashion, maybe with a 20% step. So maybe 20% of my running, let's say containers, container instances at one time, at the next period of time, 40%, at the next period of time, 60%, and so on. So we can do this, for example, in a linear fashion, or we can also do it in an exponential fashion, factor of 2, for example. Besides from defining how our configuration will reach our instances, so linear or exponential, we tell AppConfig what's the step. As I mentioned, maybe 20% of the time at a time, and the deployment time. So how long do we take to create those steps? How long do we take until 100% of our running instances of our application have got that new configuration? Maybe it's 10 minutes, 20 minutes. And we can also define a bake time. So after our application has been made available to our running instances, how long do we wait to listen for alarms that might go off, right? So how long do we give AppConfig to consider this deployment of configuration might be unhealthy because an alarm has been triggered? How long does it wait for that? That's the bake time, and it takes place at the end. And then AppConfig will only consider the deployment of that configuration to be complete if that bake time has been completed and no alarms have gone off during that period. To look at it in a bit of a more graphic fashion, we can define, as I mentioned, our deployment time. That could be 10 minutes. We have final bake time, perhaps of 5 minutes. And if we set a step of 20%, then we know that during the first 2 minutes, so we have 5 steps because we're using at 20%. And during the first 2 minutes, we will make that configuration available to 20%. On minute 6, that will be 60%. And then on 10 minutes, all of our targets can have that configuration made available. The way that our running applications or running instances of our application are going to pull that configuration from AppConfig is via the get configuration call. And the get configuration call will need to tell AppConfig which application it is looking the configuration for which environment, which exact bit of configuration. And it's also going to pass a client ID. And it's this client ID that is different per running instance of our application. And that's the way that AppConfig knows how many targets we have or how many running instances of the same application we have. And it can keep track of each of them and then know, okay, I only select 20% of those for the first step of my configuration deployment, and 20% more for the next step, and so on. Besides from what we've discussed, we also need to tell AppConfig where exactly our configuration is. So for that, we create a configuration profile. And this basically tells AppConfig how to access that underlying configuration. We again give our configuration a name. And we can store it in AppConfig, so we can have it hosted directly there, as I mentioned. Or it can use other AWS services as the underlying storage, Amazon S3, Parameter Store, which we're going to see in a minute, System Manager document, and other ones. If AppConfig needs to reach out to those other AWS services to access that underlying configuration, then it will need to have an identity and access management role. So we'll have to have the right permissions to access those services. So we'll have to grant that yourself as well. As part of our configuration profile, besides from telling them where the underlying configuration lives, we can provide these validators. These validators could be a JSON schema. So if you're working with JSON type of data, you can specify a schema. Or if you're working with different types of data, you can also specify a Lambda function. This is a serverless bit of code for you where you can specify your own logic and tell AppConfig, use this function. This function has specific custom logic to validate that configuration that we're going to deploy. And AppConfig will use that before it starts the deployment to make sure that configuration is valid and it won't break our applications. And after that, we can actually trigger a deployment for our configuration. And what that means is that we're going to deploy a new configuration version, a given configuration against one of the environments of our application. And we're going to use a given deployment strategy. We're going to ask AppConfig to use a given deployment time, a given bake time, and to do this in a linear or exponential fashion. So we can basically trigger it. We can select the version of our configuration that lives in the underlying source. So if, for example, if we're using S3 as a source, we would be able to see the different versions of the same configuration object here and select the one we want to deploy next. And so we select the deployment strategy as we just discussed. It can be a custom one that you've defined, like the one I have here, or it can be one that is provided by AWS AppConfig by default. For example, there's one called All at Once, which is very quick and could be used, for example, if you deploy to a development environment or to a QA environment. As I said, you can select the parameter version as well. That's important. And that's about it. That's really how AppConfig will roll out your configuration. And as I mentioned, it can use several underlying AWS services. we can use this regardless of AppConfig. We can also use these services to host the application configuration of our applications. These two services integrate with AppConfig. S3 is an object store, as we might know, and parameter store, which we're going to see in a second, is a key value store. It can store your key values in an encrypted or unencrypted fashion. S3 is a very low-cost service. As you might know, of course, you can look at the pricing, or you're familiar with the pricing yourself through the documentation. Parameter store has two versions. If you use the standard parameter version of the service, then there are no charges for it, even if you store encrypted data. So that's quite useful. And both of these services integrate with AppConfig, so we can use them as underlying sources. We also have Secrets Manager as another service that we can use for application configuration. And that becomes handy when we need to actually manage the lifecycle of credentials in our applications. We discussed we can have sensitive information, we can have credentials to databases, we can have old strings or old keys, for example, and we want to rotate those and limit that lifecycle. That is what Secret Manager can help us with. If you don't need to rotate your credentials or secrets, you can simply use Secrets Manager, Parameter Store, and even encrypt them if you want. But Secret Manager does provide that lifecycle management of the secret for you. And because it does lifecycle management for you, it doesn't integrate with AppConfig, but it's still a very useful service that you can use within your applications. Let's take a look at Systems Manager Parameter Store and how to use this. As I mentioned, it's a managed service. It will help us separate our configuration from our code. It's a key value store, and it actually has the very nice feature that we can notify our applications or trigger automated actions if those parameters changes. So we can tell Parameter Store to let us know about those configuration changes. We can integrate this into our custom applications, whether they are running on AWS or whether they are running on premises or wherever else. And other AWS services can also use Parameter Store. We can define in Parameter Store key values of type string. That's pretty clear. A string list, so a list of textual values. And we can define the so-called secure strings, which are the encrypted versions of our parameters. And that is how the UI would look like if you would use this via the console. Parameter Store also has a specific organization for our parameters. It lets us prefix or use a path-based organization for our parameters. So, for example, you can use a prefix such as config, then your application name, for example, and then the specific name of the parameter. Or you can even include the environment or the lifecycle stage for that application, and then your parameter name. Parameter names are insensitive, and they cannot include spaces, so they look more or less like this here. You can, as I mentioned, use them as a source, or use Parameter Store as a source for AppConfig and then integrate AppConfig in your applications. Or you can also integrate Parameter Store directly with a Spring Cloud AWS. So you include the Spring Cloud Starter for AWS, and then you include the AWS Parameter Store config module, that dependency, and that will allow you to work directly and transparently with Parameter Store as a bootstrap property source. A Spring Cloud AWS will assume some convention for the naming of the parameters. So we'll always assume that you're using config as the prefix, then the Spring application name, and then the Spring underscore Spring profile, and then the parameter name. But we can override that. We can use the bootstrap YAML file or bootstrap properties file to set up an alternative name that Parameter Store should use for the prefix. And after the prefix before our parameter name. So it doesn't have to always use this convention. You can modify that. After that, we can simply access those properties via our code, via the regular annotations that we're familiar with. In terms of notifying our applications or getting notifications about parameter changes, which I mentioned, we can tell Parameter Store to send those events to another service, a bus, which is called Amazon Event Bridge. And when those events land on the Event Bridge, we can activate the notification service at AWS, which is called Amazon SNS. And Amazon SNS can notify applications. Actually, it can send emails, it can send any type of notifications. So you can get that in any other form that you want as well. But it can also trigger HTTP post requests. And that way we could, for example, invoke our Spring Boot refresh actuators to force that refresh of properties, to force that reload of properties for our application. For example, if you're running also on Elastic Beanstalk, not just containers, this can be a way to do that. And your application will need to confirm that it approves SNS to keep on pinging it by HTTP post every time that there is a change in one of the relevant parameters. But that only needs to happen once, and after that, our application, our refresh actuator can be invoked every time there is a change, and we can refresh that configuration in our application. Another nice feature, if you use the advanced or paid version of the parameters in Parameter Store, is that you can define an expiration for your parameters. You can also define to get notified upon expiration. So you again can get notified via events to this and act on that or react on that. Or you can also get notified of a no change over a period of time. If your parameter didn't change over a period of time, and that's not a good thing in terms of the lifecycle management of your parameter, then you can also get a notification and act on that. So that was Parameter Store. And as I said, you can also encrypt the key values, the values of the key values that you store there, but it doesn't provide you any rotation facilities, doesn't provide you any lifecycle management for your most sensitive part of configuration, your credentials. But actually, what do we mean with that sensitive part? What are exactly those secrets? If we look at one of the definitions provided by one of the standard institutes, it is really any value that an attacker or a malign agent could use to impersonate you, impersonate the user, impersonate the application in an authentication protocol or process. So we're talking really about credentials, and we really would want to rotate them periodically. We want to reduce that risk of secrets being leaked and being misused by limiting that life cycle. For example, of database credentials or SSH keys that lets us get into other environments. And of course, we need then to distribute those credentials to our applications to be used, but we want to do this in a secure manner. We want to make them available without actually exposing them. And we really want them to be available for applications in a timely fashion, so that if the database credential changes and a new database connection needs to be established, then we don't want our application to have any downtime because it's not using the correct new values. Secrets Managers helps us do that. It's really about rotation. So if you don't have that need for rotation of your configuration, then you can simply use Parameter Store, encrypt those, and that service will not cost you anything. Secrets Manager is a paid service besides from the trial period that you get, but it really provides you that functionality to manage the life cycle. After you define a key value, you can enable that automatic rotation. You set the interval for that rotation. And for our services, for our database services, or some of the AWS services, we already provide the Lambda function, the logic to do that rotation, and you can just use that. Or if you're using a custom database or any, or you want to implement your own logic for rotating, then you can implement your own Lambda function and specify it as part of your Secrets Manager configuration, and then use that going forward. It also, I mean, that's just another of the features. It will eliminate the need of you to provide secrets in plain text, also when you're working with other services. So if you create AWS resources of any other kind, you can also tell those resources to go to Secrets Manager and retrieve those credentials. You never need to pass them as plain text. Encryption is done with the usage of the key management service at AWS. So KMS will actually provide the encryption keys for Secrets Managers to perform that encryption and store that value in an encrypted form. You can define fine-grained access to each of the key values that you define, or each of the secrets that you define in Secrets Manager, with what we call identity and access management policies. And as I mentioned, the rotation logic for AWS databases such as RDS, DocumentDB, Redshift, and others is already provided for you, or you can create your own. Secrets Manager is not an underlying source for AppConfig, as I mentioned, but you can integrate it directly in your Spring applications, also by including the Spring Cloud AWS Starter module for Secrets Manager, and then simply with annotations use it in your applications. There is nonetheless also another library which is quite handy when working with SQL databases, not just AWS managed databases, any sort of SQL database that uses a JDBC library or a JDBC driver. You can use this Secrets Manager JDBC dependency, and then as part of your application configuration, you can point that you can define the username as actually the secret in Secrets Manager, where you can retrieve all the information about the database, the host name, the port, the username, the password. And this library would simply pull all that information from Secrets Manager and inject that into your JDBC driver transparently. Then it will actually cache that information for a period of 1 hour, and then refresh that constantly so that new connections can use the fresher data if there should be some fresher data to be used. So that's actually also quite handy and really very transparent way of working with Secrets Managers and having a quick JDBC driver configuration. Putting it all together, and to start recapping here, we looked at how to manage stage deployments of configuration, separating it from our code and doing this in a step fashion, doing validation, and doing rollbacks as well. And that was done with AWS AppConfig, which we integrate into our Java Spring Boot applications via the AWS SDK. We also looked at how to manage configuration, so the underlying storage, for example, with AWS Parameter Store, which is a source for AppConfig, but we can also integrate directly with a Spring Cloud for AWS. And we also looked at how to rotate secrets, sensitive parts of our information, limited that life cycle, and how Secrets Manager helps us with that, and how that integrates also with our Spring Cloud AWS, through our Spring Cloud AWS in our project. A final note, I have to keep it a little bit shorter than usual, so no time to go into infrastructure as code in detail, but just to let you know that CloudFormation templates can access AppConfig configuration, AppConfig-based configuration. It can access parameters that you store in Parameter Store, and also secrets that are included in your Secrets Manager configuration. So you can use that. You don't have to provide those values textually. You don't have to hard code any configuration in your CloudFormation template. So your infrastructure as code doesn't have to have anything hard coded there. And that's true also if you're using AWS CDK, which is the new or newer way of providing programmatic definitions for your cloud configuration. It also has libraries, construct libraries for working with AppConfig, Parameter Store, and Secrets Manager. So through both of those services, you never have to hardcode configuration of secrets when you roll out cloud configuration or infrastructure for your application. So please use that. That's the best practice. And with that said, I'm happy now to close this talk. I'll be happy to take, of course, some questions now. But before I finish, I'd like to kindly ask you to please complete a 1-minute set of questions. It's really very short. I appreciate your feedback. I'd like to improve on the topics that I present, on the way I present to you. So please let me know what you think and answer this short survey. And with that said, I'd like to thank you and happy to take some questions. Any questions from the audience, perhaps? In case you would like to answer the survey and provide me some feedback, I would be pasting the link in the chat for everyone. So that would be quite helpful for me.
Hi, Clemens Guggenberger here. I have a question.
Sure.
You said in the beginning that storing the credential or baking the credential in the image is an anti-pattern, and said, well, better way would be to use environment variables and to pass the active string profile as a method to do that. But that doesn't help at all with the secret problem and leaking secrets, right? So for for handling secrets and not leaking, I would always have to refer to something like Secret Manager or encrypting it in the
or Kubernetes secrets and so on. Yes, that's correct. Yeah. So I would also not recommend to pass sensitive information ever as environment variables. This is not the best way to do it. What is meant is you can pass the Spring profile, the active Spring profile that helps your application, for example, pick up the correct application.yaml file. And within the application.yaml file, you can also reference Secrets Manager. So, for example, in the YAML file, you can use the YAML notation, use the expected Spring convention that the Spring Cloud config library for Secrets Manager is expecting you to use for the secret. So config, application name, and so on. And through your application YAML, you can tell them go to Secrets Manager, or you can tell, and that's a better way to do it. You just give them, hey, use that application YAML, and that YAML points to Secret Manager as well, and that's what I meant.
Okay, so it's kind of like you're building on top of that approach with a profile, and then separating from the profile, separating it out to where the secret is actually stored.
Yes, that's and that helps you pass. You also don't want to pass at runtime 500 different bits of configuration. So if you pass the Spring profile and your YAML file can point somewhere else to the respective places, that's more handy, I think.
Okay, thank you.
During the startup of your application, so Secrets Manager can be used or is going to be used also as a bootstrap property source. So when your application bootstraps, the Spring has a sequence of where to look for your bootstrap properties, and it will also, when you include the dependency, look in Secrets Manager to be able to retrieve that. So that happens during the startup of the application or your Spring Boot application as well. That's what I just read I read this question on the chat. When you want to define that as environment variables, that depends a lot, for example, on how you're working with where you're deploying your application. For example, in Elastic Beanstalk, you can define this if you deploy your Java Spring application in Elastic Beanstalk. Elastic Beanstalk obviously helps you or has a facility for you to provide environment variables for your application, and you can refer, you can point to Parameter Store, you can point to Secrets Manager as well through those environment variables. As I said, AWS services can reference those services as well, and that integration makes it quite handy when working with applications in the cloud. Thank you. All right, so if there are no more questions, I would like to thank you and get myself some more coffee and wish you a great rest of the today and conference to everyone. And thank you to our moderators for their support. Thanks a lot.
Thank you.